Hey guys, good morning. So, to explain to you what happened. So, I have been watching a video on physics stuff, and on this video, it was like an hour long. I only watched like 5 minutes of it, and then I thought, you know, I need to record my chemistry and math stuff, so I did. Now, when I open this recording software, okay, which you can see right here, when I open this software, it mutes my headphones, so I can't hear it. So I didn't realize the video was still playing. I had a setting in here called audio output capture. Okay? It's called audio output capture, which means that anything outputted by the computer is recorded in the video, which means that the whole time I was teaching chemistry and math, that physics video was playing in the background, and I couldn't hear it, but you could. So when I put the video into my video editing software, all I could hear was this guy yelling about physics. And I'm thinking, what is going on? Because I couldn't hear it, but it's because it mutes my microphone. So that's how I lost everything. So let's try this one more time. Okay, so shorter lesson today. Um, we are on page, I don't know, 414. And what we're talking about today is the pH scale. Now, yesterday we talked about hydroniums and hydroxides, right? The H3O and the OH minus. OH or H3O plus and OH minus. And we said that H3O plus has way more H's in it. And those H's are protons, and the more protons you have, the more acidic you are. Great, right? And we learned to solve for the OH content and the H3O content, and we decided that the concentration in pure water of H3O plus and OH minus are both 1.0 times 10 to the negative 7. So, today we're going to use that because believe it or not, the silly thing that we've been talking about since we were in middle school, the pH scale from, from 0 to 14, is actually done using those crazy big numbers. We just didn't know it. So, acids and bases, the pH scale. Here is how we're going to define it, okay? The pH scale. Please write these notes. I already wrote them in the last time I recorded this video. The pH scale. Number one, pH is a way to describe ion concentration without scientific notation. pH is a way to describe ion concentration without scientific notation. Ion concentration basically means how much H3O plus you have and how much OH minus you have. The pieces that make up this unit, the two ions, the acidic one and the basic one, how are you going to write them? pH gives you a way to write them without having to use 1.0 times 10 to the negative 7. That's a mouthful. And we'll show you how. Number two, the pH of a solution is the negative logarithm of the molar hydronium ion. Sounds really complicated, but I promise it's not. The pH of a solution is the negative logarithm. In other words, that's the math term right here, negative log. So the pH of a solution is the negative log, which you can type into your calculator, by the way, of the number for your H3O plus. That's all it's saying. The pH is the negative log of the concentration of your molar hydronium ion. And this equation is literally as complicated as pH gets. Tomorrow we'll be talking about pOH, and that gets a little weird. But today we're just talking about pH. So basically, we're about to prove number one by doing number two. So the pH of pure water, okay? We said that it's 1.0 times 10 to the negative 7 for the hydronium and the hydroxide. So let's test that. So the pH equals negative logarithm of H3O plus. I know that I have 1.0 times 10 to the negative 7, so I'm going to plug that in for H3O plus. pH equals negative logarithm of 1.0 times 10 to the negative 7. Now, it's really hard to take a negative log in the calculator, so usually what I do is I type this into the calculator, get my answer, and then put a negative in front of it. That's usually what the easiest way to do it is, and I'd recommend not using negative logs in your calculator. So when I took that, I ended up with negative 7.0, and my negative is still carrying down from the top. So now I have negative 7.0, and what do I get with that? 7.0 is my pH. And you probably remember from grade school, or from middle school, that the pH of pure water is 7, and 7 is neutral. 7's in the middle. That's because we have a lovely little scale, which I wish I could I'm going to rewrite it because I'd rather you see me write it and write it along with me for this one. So in our lovely little scale, we basically had something between 0 and 7, and then something between 7 and 14. And we said, back in the day, that if it's between 0 and 7, that means it's an acidic solution. Where's my blue? And if it's over here, it is an alkaline solution. Alkaline. Alkaline just means basic. But basically from here on out, I'm not going to use the word basic. I'm going to use the word alkaline. Because in college chemistry, they're not even going to say the word basic. They're going to use alkaline. And so I want you guys, that's the more scientific way of saying it. So just know that I'm saying alkaline, I'm actually saying basic. So we have the acidic solution down here and the alkaline solution here. What does that mean? I got pH equals 7. Yay! What does that mean? Well, first off, if you have a 7, that means you have a neutral solution. That means it's not acidic or alkaline. But what acidic really means is more H3O plus. And what alkaline really means is more OH minus. That's what these are really saying. Alrighty. So this little chart is going to come in handy. So I'd keep this page of notes accessible. We'll be referencing this quite a bit. So, with that being said, I just have to do 2 problems with you. And then I'm going to leave you to your own devices and check that out. The lesson's over in 6 minutes and 50 seconds. New record. So, on page 415 in 16-2, the book asks you, what is the hydronium ion concentration in shampoo? Oh, I'm sorry, no, it says the hydronium concentration in shampoo is, my bad, 2.0 times 10 to the negative 5 molar. And remember, molar is just a unit of concentration. What's the pH? And you don't have to copy this problem down with me, because it's in the book. But the hydronium ion concentration in shampoo is 2.0 times 10 to the negative 5th molar. What is the pH? What am I supposed to do? I don't know. Actually, no, I'm kidding. I'm the teacher. I do know. So we have equation. I just said like we have equation. And it was pH equals the negative log of the hydronium concentration. Does the problem give me the pH? No, I'm looking for the pH. Does it give me the hydronium concentration? Yes, it does. So I'm just going to plug that in. pH equals negative log of my concentration. 2.0 times 10 to the negative 5th molar. Fantastic. Now, if you type in log of 2.0 times 10 to the negative 5th, This actually ends up giving you negative 2.2. Now remember what I said? I'm not even going to deal with this negative until the very end. And I recommend you do the same. So then you have negative 2.2. So your answer ends up being positive 2.2. Hey guys, just a quick note. I accidentally wrote the answers in from a different problem here. When you type in log of 2.0 times 10 to the negative fifth in the calculator, you actually get negative 4.7. So then negative 4.7 gives you positive 4.7 as your pH. I apologize for that. That's your pH. Does that seem dreadfully hard? I sure hope not. Basically, all you're looking for is your hydronium content, then you use your calculator to type in the log of that hydronium content, and then you're good to go. If you do not have a if you don't have a graphing calculator that has these buttons like log and stuff, there's actually an app for your phone um, that is a digital graphing calculator. That's pretty awesome. Um, I'll figure that out and let you guys know tomorrow where to get it. But let's do the second problem, 16-3. It asks, what's the pH of an aqueous solution of 0.40 grams of HI dissolved in 500 milliliters of water? Okay, so this problem doesn't look nearly as cut and dry as the last one, but I'll start with the equation anyway. pH equals negative log of the hydronium concentration. Okay, do we have our pH? Nope, we're looking for our pH. Do we have a hydronium concentration? Doesn't look like it. So what are we supposed to do? What was the unit here in the last problem? Molar. What does M mean? M means moles over liters. Yay, we do have milliliters. It looks like we're just going to have to solve for our M first. And we've done that in the last section. So this shouldn't be too hard, but let's do it. So if my M equals moles over liters, then what would my liters be? 500 milliliters. All right. And I don't have moles, so I guess I'm just going to have to settle for grams. So these grams need to be moles, and these milliliters need to be liters. So I've got some conversions to do. So how do I get milliliters into liters? Well, if I want it to be liters, I got to write 1 liter here. Then how many milliliters are in a liter? 1,000 milliliters. These cross out. Okay, so my bottom is right, and my top's wrong. Grams. How do I get grams into moles? Well, I want it to be moles up here. If you want to go grams to moles, you have to multiply, or you have to divide by the molar mass. What's the molar mass of HI? I have the advantage of actually having done this problem. So the molar mass of HI is 127.9 grams of HI, which means that my grams of HI cancel out, my milliliters cancel out, and I'm left with moles and liters. Perfect. And I can tell you right now that when you plug this into your calculator, zero point 0.4 times 1,000 divided by 500 and divided by 127.9, you end up with this number. 6.2 times 10 to the negative 3 molar. And hey, molar, that's convenient. That's exactly the unit I need to plug in here. So I will. My pH equals negative log of 6.2 times 10 to the negative third. Fantastic. Now when I type in this into the calculator, pH equals The log of 6.2 times 10 to the negative third gives me negative 2.2. No, wait. Yeah, gives me negative 2.2. And like I said, I'm just carrying this negative down to the bottom. I'm not even putting the negative in the calculator because I don't want to deal with that. Negative 2.2 gives me positive 2.2. That is the pH of my solution. So, for homework for you guys, I've come up with two problems that are super similar to the ones I just did with you, and one problem from the book. Just three problems for homework. There you go. So, let me make sure all this can show up. There we go. Three problems for you for homework. Let me know if you have any questions. Remember that today there's a quiz on Quizalize. The link to the class code will be in the description, and that should be up sometime around 9 o'clock. And I'll have it open for the rest of the day. So good luck on that. Um, that quiz will only have one attempt, given that I've given you the questions ahead of time. I think that's fair. So, hope you guys have a wonderful day.